Hello and welcome you all to this video lecture series on chapter Introduction to Powder Metallurgy. In last lecture we have seen the next steps in powder metallurgy, that is a sintering process and secondary operations which has to be done on the sintered powder metallurgy product. In today's lecture we will see what are the advantages, limitations and applications of this powder metallurgy. Now, in first lecture only, we have seen some significance of the powder metallurgy. These significance are nothing but the advantages of the powder metallurgy. In that significance, we have seen the processing and combinations of the materials that would otherwise be impossible to mix by other processes are done by powder metallurgy. Processing of the materials with the very high melting points can be done by the powder metallurgy. Products with the controlled level of porosity can be done by powder metallurgy. Methods with the superior properties and microstructure can be done by the powder metallurgy, and powder metallurgy is cost effective. These all are the significance as well as the advantages of powder metallurgy. Due to these significance, we are using mostly in many applications the powder metallurgy process. Other advantages includes the production of net shape and near net shape made of expensive materials. So we can produce any kind of shape, net shape, with the help of this powder metallurgy. Secondly, the powder metallurgy process is capable of less than 3% scrap. So the major advantage of this powder metallurgy is less scrap produced. So whatever scrap that can be produced in other production techniques, it is very less as compared to those methods in the powder metallurgy. Bearing, especially so called as a permanently lubricated bearing, in which air pores in the powder metallurgy parts are filled with the oil by the process of impregnation, can be done. So in significance also I have mentioned that the products with a controlled level of porosity can be manufactured by the powder metallurgy, and that is the advantage. We can produce the self lubricated bearing with the control amount of porosity so that they can be oil impregnated and can be used in actual application. This is the advantage. Next, the parts of certain metals and metal alloys that are difficult to fabricate by other methods, such as a carbide tool insert, tungsten and ceramic. These are difficult to produce by other methods, and these can be fabricated by the powder metallurgy methods. Next, parts of material with a special and unique properties. Alloys that can be produced by the other processes having the special and unique properties can be prepared by the powder metallurgy. Next, parts can be made from a great variety of composition. So the powders of different materials or different metals can be added, as well as some other additives can be added, such as lubricant and other colorants can also be added. So the parts can be made with a great variety of composition by powder metallurgy method. This is also a one kind of advantage. So after these advantages, we will see the limitations or some disadvantages of powder metallurgy. It is generally having a high tooling cost as compared to other. It is cost effective generally for some cases, but for some cases it is requiring high tooling cost. Expensive raw materials, because for producing powder we require some different methods and different machining tools, so that will become expensive to form the raw material. Variation in the material density. The density variation is there, and that can be controlled by controlling the applied pressure and sintering process, but the variation in material density is there, and the mechanical property across the volume. Depending on how you are applying the pressure, there will be the density differences across the volume. Relatively long parts are difficult to manufacture. Complex geometries generally we cannot prepare by the powder metallurgy. This is the biggest disadvantage of powder metallurgy. Difficult for storing and handling the powders. So there is very big disadvantage that there may be degradation with the time, there may be fire hazards, there may be oxidation process, occurring with the powder which are stored. So it is difficult to store and handle the powders. Next disadvantage, large or complex shapes are difficult to produce by powder metallurgy process that we have seen. Uniformly high density products are difficult to produce. Uniformly dense parts are difficult to produce. We require to apply equal amount of pressure from all sides. Then there may be chances of production of a equally distributed density across the part. Parts have the lower ductility and strength than the parts produced by forming. So by parts produced by forming are having higher ductility as well as strength than this. The ductility produced by this is generally lower, as strength also generally low. These are the few limitations of the powder metallurgy processes. Then applications of powder metallurgy. Generally, these powder metallurgy components can be used in everywhere, such as in automobile components, aerospace components, industrial machine parts, electrical motors, electronic industry, medical appliances also. There is a great variety of machine components that are produced from the metal powder. Many of these are put to the use without any machining operation carried out over them. Some examples of this powder metallurgy in actual is self-lubricated bearing, cemented carbide cutting tools, friction materials, filters, cutting tools and dies, machining parts, magnets and electrical. So apart from that, powder metallurgy methods can be also used in a biomedical fields also. The new researches are going on this field. The powder metallurgy of biomaterial is still a huge market, but considerable progress in relative manufacturing techniques are there. The powder metallurgy techniques like metal injection molding are promising manufacturing routes for the large areas in biomedical field. The bones similar to our bones with the porosity, with the controlled porosity, can also be prepared by this powder metallurgy. And powder metallurgy is a popular metal forming technology used to produce the dense and precise components. Different powders of a component forming the roots can be used to create an end product with the specific properties for the particular application in the industries also. The advances in powder metallurgy explores the range of materials and techniques that are used for powder metallurgy, and the use of this technology across the variety of application areas are there. So these particular applications also we will see in the further next videos. In next video we will see the flow diagram or how to produce actually the self lubricated bearing as well as cemented carbide cutting tool and friction materials. So these details we will see in the next video. Thanks for watching.